Have you ever wondered how Google Maps shows real-time locations or how cities analyze pollution data? This is possible because of geographic information systems and remote sensing. In this VAC course, you will learn the fundamentals of GIS and its real-world applications. Hello students, welcome to this value-added course on fundamentals of GIS and remote sensing applications. I am Dr. Brijesh, Assistant Professor from the Department of Civil Engineering, MERI College of Engineering and Technology. Welcome you all. I welcome you to the value-added course titled as Fundamental of GIS and Remote Sensing Applications. This course is designed to introduce students to modern geospatial technologies that are widely used in engineering, environmental science, planning and research. In this first unit, we begin with an introduction to Geographic Information Systems or GIS, which forms the foundation for the understanding spatial data analysis. Today, location-based technology is deeply integrated into our daily lives. When we use mobile navigations, check traffic conditions, track delivery routes or view satellite images online, we are interacting with systems built on geographic information. GIS provides the scientific and technological framework that allows these systems to function efficiently. The purpose of this course is to build conceptual clarity about how geographic data is collected, stored, analyzed and visualized. Many students assume GIS is only about maps, but in reality, GIS is a decision support system that helps professionals understand patterns, relationships and trends connected to locations. This makes GIS an important interdisciplinary tool. In civil engineering, GIS is particularly useful for infrastructure planning, land use analysis, water resource management and transportation design. Engineers often work with geographic conditions such as terrain, soil distribution, drainage patterns and population density. GIS helps integrate all these data sets into a single analytical platform. This course will follow a concept-based learning approach supported by visual examples and real-world case discussions. Instead of focusing immediately on software tools, we will first understand the logic behind spatial analysis. Once the concept is clear, practical implementation becomes much easier. Another important goal of this VAC is to develop spatial thinking skills. Spatial thinking means understanding how objects relate to each other in space and how geographic patterns influence planning decisions. These skills are valuable not only in engineering but also in environmental monitoring, disaster management and smart city development. As we move through this course, you will see how GIS integrates with remote sensing, GPS technology and digital mapping systems. Together, these technologies allow us to study Earth's surface in ways that were not possible in the past. By the end of this session, you should feel comfortable with the idea that GIS is not just a technical subject but a practical system used to solve real-world problems. This introductory lecture sets the stage for deeper exploration of GIS concepts in the upcoming sessions. Let us now look at the learning objectives of this unit. In this session, we focus on 4 key learning objectives that help build a strong conceptual foundation for GIS. These objectives guide what students should understand by the end of this lecture and ensure structured learning. The first objective is to define GIS clearly. Understanding the definition helps students recognize GIS is a system that integrates geographic location with information. Many technologies use data, but GIS is unique because it connects data to spatial coordinates. This ability to link information with the location makes GIS powerful. The second objective is to understand the importance of GIS in modern applications. GIS is used across multiple sectors including engineering, agriculture, environmental science, transportation and governance. By understanding its importance, students appreciate why GIS has become an essential technological skill. The third objective is to identify real world applications of GIS. Learning becomes meaningful when theory connects with practice. When students see GIS used in traffic mapping, flood monitoring, pollution analysis, and city planning, the subject becomes easier to understand and remember. The fourth objective is to understand how GIS supports decision making. Decision making improves when information is visualized geographically. Maps reveal patterns that tables of data cannot easily show. For example, mapping accident locations on a road network can quickly reveal high risk zones. These objectives also prepare students for future modules in this way. Before learning spatial data models or remote sensing, it is important to understand why GIS exists and how it is used. Learning objectives also help instructors maintain focus during teaching. They ensure that explanation remain aligned with students' outcomes rather only theoretical discussions. By achieving these objectives, students' confidence in understanding GIS terminology and applications. This confidence becomes important when learning advanced topics such as spatial databases and satellite imagery. In summary, learning objectives provide direction, clarity, and measurable outcomes for the session. They ensure that the students leave the lecture with a clear understanding of GIS fundamentals. Now that we know what we aim to learn, let us begin with the definition of GIS. What is GIS? A geographic information system is a computer based system designed to work with geographic or spatial data. GIS allows us to capture, store, manage, analyze and visualize information connected to locations on earth. The most important idea behind GIS is the connection between data and location. Every geographic object exists somewhere on earth and GIS records that position using coordinates. Once data is linked to coordinates, it becomes spatial data that can be mapped and analyzed. For example, consider a data set showing rainfall measurements across different cities. If this data is stored only in a table, it is difficult to interpret patterns. When plotted on a map using GIS, high rainfall and low rainfall regions becomes immediately visible. GIS performs several important functions. It collects data from sources such as surveys, GPS devices and satellite imagery. It stores this data in digital databases. It analyzes spatial relationships between datasets. Finally, it presents results through maps and visual models. A familiar example of GIS is Google Maps, which combines road networks, satellite imagery and navigation algorithms. This demonstrates how GIS integrates multiple data sets to provide useful information. GIS helps answer spatial questions such as where is something located, what exists at a location, how has a location changed over time, what spatial patterns are visible. These capabilities make GIS a powerful analytical tool rather than just a mapping system. By transforming geographic data into visual information, GIS helps users understand complex relationships quickly and accurately. Now, this is a question, why GIS is important? GIS is important because it improves the way we analyze geographic information and make planning decisions. When data is visualized on maps, patterns becomes easier to understand and solutions become easier to design. In urban planning, GIS helps analyze land use patterns and infrastructure's requirements. Planners can identify areas suitable for residential development or transportation network. In transportation engineering, GIS helps identify congestion zones and optimize routes. In environmental monitoring, GIS helps track pollution levels and land cover changes. In disaster management, GIS helps identify vulnerable regions and plan emergency response strategies. GIS allows integration of multiple datasets into a single analytical environment. This integration improves accuracy and reduces uncertainty in planning. Because of these benefits, GIS is widely used by engineers, researchers, and policymakers worldwide. Now, what are the elements of GIS? GIS integrates maps, data, technology, and analysis tools into a unified systems. Maps provide visualization, data provides information, technology enables processing, and analysis tools generates insights. GIS answers spatial questions such as where, what, how much, and what changed. By combining these elements, GIS becomes a powerful decision support system.
At this stage, it is important to understand that GIS is not just about maps but about thinking in terms of spatial relationships. Let us take a simple example to understand this concept better. Imagine you are planning to open a new hospital in a city. Now, this decision cannot be taken randomly. You need to consider multiple factors such as population density, distance from existing hospitals, road accessibility, availability of land, environmental conditions. Now, if you try to analyze all these informations in the form of tables or reports, it becomes very difficult to interpret. However, when this data is placed on a map using GIS patterns becomes immediately visible. You can easily identify which areas are undeserved, which locations are highly populated, and where accessibility is better. This allows planners to make informed and efficient decisions. This is the real strength of GIS. It converts complex data into simple visual insights. Another important concept is that GIS helps us understand relationships between different datasets. For example, if we combine a map of pollution levels with a map of pollution density, we can identify areas where people are most affected by pollution. Similarly, if we combine rainfall data with elevation data, we can identify flood prone areas. This ability to combine and analyze multiple layers of information is what makes GIS extremely powerful. Now, let us briefly discuss how GIS is evolving in today's world. With the development of technologies such as artificial intelligence, big data, Internet of Things, satellite imaging, GIS is becoming more advanced and widely used. Today, GIS is used in smart city development, real-time traffic monitoring, disaster prediction systems, climate change analysis. This means that GIS is not only a current technology but also a future-oriented skill. From a career perspective, learning GIS opens opportunities in engineering and infrastructure planning, environmental consulting, urban development agencies, government planning departments, research and data analysis. Many organizations today require professionals who can understand and analyze spatial data. So, as students developing a basic understanding of GIS will not only help in academics but also improve your technical and analytical skills. Now, before we conclude, let us connect everything we have learned. GIS helps us understanding locations based data, analyze spatial relationships, also visualizing patterns, supporting decision making, and most importantly, GIS helps us solve real world problems in a systematic and scientific way. That's all for today. See you in the next lecture. Thank you.